Good morning to all. Now, in earlier video from the unit number 5, we have seen the design of cylinder and the one problem based on the design of cylinder. Now we will see the second component is a cylinder head. Now the cylinder head is assumed as a flat circular plate which is on at the top side of the cylinder, which is on that cylinder head. The various components are mounted. So first equation for the thickness of a cylinder head. So there is a formula for finding out the thickness of a cylinder head. It is denoted by small t suffix h. So that th is equal to d into square root of k into p max divided by sigma c, where th is the thickness of cylinder head and k is the 0.162 and it is taken as a constant, where sigma c is the allowable circumferential stress in Newton per meter square, where Pmax is maximum gas pressure inside the cylinder in Newton per meter square of megapascal, or it can be taken as a 10 times of the Pm, that Pm is nothing but indicated mean effective pressure in MPa on Newton per meter square. That in MPm is earlier we have seen in design of cylinder, where the formula is Ip is equal to Vp upon efficiency, where Vp is equal to indicated mean effective pressure into length into area. So that earlier we have seen this. Now the circumferential, the second equation is the circumferential hoof stress. It is divided by sigma c, or you can say the circumferential stress, hoof stress, or you can say circumferential stress. So that sigma c is equal to sigma t, where sigma t is the allowable tensile stress, and the formula will be used as a SUT is the ultimate tensile strength, the factor of safety. Okay, that Fs is the factor of safety and ultimate tensile strength. It is the ratio of ultimate tensile strength to the factor of safety is nothing but the circumferential stress. Now sigma c is equal to, it should be in 30 to 50 Newton per mm square. That is allowable is 30 to 50 Newton per mm square. If your value coming in that range, then your design will be the same. If your value is going above 50 or less than 30, then your design will not be same. So on based of factor of safety, we will design the cylinder head. Now the design of studs for the cylinder head. Also studs means what? Why the studs are used? To provide the link-proof joint between cylinder and the cylinder head. The what you can say, studs are tightened to give or induce a preload, and the studs are subjected to the tensile stress due to the internal gas pressure. So the first equation, number of studs. How to find out the number of studs? So that Z is equal to 0.01d plus 4 and 0.02d plus 4. There is a minimum number of studs and this is the maximum number of studs. Yes. So minimum and maximum number of studs you can find out by using this two formula. Now the diameter of studs. How to find out the diameter of studs? So the core diameter of studs obtained by equating the maximum gas force acting on the cylinder to resisting force offered by all studs. So gas force acting on the cylinder cover is equal to pi by 4 d square into P max, and the second equation, the resisting force which is offered by the all studs is equal to Z into pi by 4 d square into sigma t, where sigma c is the circumferential it is core diameter and sigma t is the allowable tensile stress. So by using these two formula, you can find out the gas force acting on the cover and the resisting force offered by all studs. So equating this equation number 1 and equation 2, here we'll get pi by 4 d square into P max is equal to Z into pi by 4 d square into sigma t, where DC is the core or minor diameter of studs, Z is the number of studs. Okay, here is minimum and maximum number of studs are there, and the sigma t is the allowable or T is for the tensile stress of the stud material. Sigma T is nothing but yield strength to the factor of safety. Then that sigma T should be in 35 to 70 Newton per mm. So the nominal diameter of stud, how to find out the nominal diameter? D is equal to core diameter to the point A. This ratio should be taken and you can find out the nominal diameter. Then third equation, pitch of studs. So pitch circle diameter of the studs will be find out dp P for the pitch. dP is equal to d plus 3 times d, where pitch of studs is equal to pi into dP upon z. So if you see, there are the only formulas will be there for each and every design of a IC engine component. So you need to remember, you need to keep in mind the formulas this on this components. So to obtain a leak-proof joint, the pitch of the stud should be between two limits, that is minimum pitch and the maximum pitch. So to obtain a leak-proof joint, so minimum pitch, how to find out? It is 19 into square root of small t, and the maximum pitch is 28.5 into square root of small t. So the studs are subjected to the fluctuating load due to the variation of a gas pressure inside that cylinder from 0 to Pmax. So here we will see one unsolved problem based on the cylinder head. So just read the problem statement. The bore of the cylinder of the four-stroke diesel engine is 120 mm. Here they have given you the bore diameter, you can say, of the cylinder of four-stroke engine. The minimum gas pressure inside the cylinder is limited to 4 MPa. The cylinder head is made of cast iron and allowable tensile stress is 40 Newton per mm. So determine the thickness of the cylinder head. Here we have to find out the thickness of the cylinder head. Then the studs which are made of steel have allowable stress as 50 Newton per mm square. Calculate the number of studs, that is head, nominal diameter of studs, that is d, and the pitch of studs. That three terms we have to find out by using this given data. So what is the given data? They have given you the d is equal to 120 mm. Here you can see here the bore diameter of cylinder, that is 120 mm. Then maximum pressure is 4 MPa. Then tensile stress is 40 Newton per mm square, and the K factor is 0.162. It is constant, and then we have to find out the thickness of the cylinder head. So here solution is used, that is formula TH, that is thickness of the head, is D into square root of K into P max by sigma C. Here they have given you the tensile stress as 40 Newton per mm square. So just we put the value TH is equal to diameter is 120 into square root of K, that is 0.162. Diameter is there, K is there, into 4, P max is 4 MPa divided by sigma C is 40. So here sigma C is a 40, that is sigma T is equal to sigma C. Circumferential stress, if we consider as a tensile stress, then we will put here 40, and here we will get the thickness of the cylinder is 15.27 mm. Then we will find out the number of studs. So the minimum number of studs is 0.01 into, that is D, here is the capital D plus 4, so 0.01 into 120 plus 4 is 5.2, and maximum number of studs is 0.02 D plus 4, that is 0.02, 120 plus 4 is 6.4. So the number of studs should be from 5.2 to 6.4. So 5.2 means you can say 6 or 5 to 6. So 5 to 6 studs should be required for the particular problem step. So here we have finished the cylinder head, and the next part, in next video we will see the cylinder line. So design of a cylinder line. Thank you.